Okay, this is video 5. Now, one thing I want to point out is that this video is going to be only for my 3rd and 4th period, so that's Miss Nichols. If you have Miss Sandu or Miss Kennedy or any of the other chemistry teachers at our school, or maybe you're not even at our school, you're somewhere else, then you probably have this. The way you know if you need to know this for your test is if you see this in the grade book, then this is something you need to know. If it's not in your grade book, then you were not taught this and you were not assessed and you don't need to worry about this, okay? So when we look at percent composition shows the percentage of each element that is in a compound, okay? So remember, a compound has multiple elements. And so the formula for percent composition is, let's write this out, and I wish I had left myself more room, but percent composition is equal to the grams of your element divided by the grams of your compound, or the total, times 100%. Now, again, remember, anytime we're doing these percentages, do not put in your calculator. Don't put the percent sign in your calculator. It's kind of like a unit, like you wouldn't put a G for grams in your calculator. So if we want to find the percent composition of Cl2O7, okay, dichlorine heptoxide. It's been a while since I've had to pause there and think for a second. But when we look at our element, it doesn't mention a specific element, so this means that I need to find the percent of chlorine and the percent of oxygen. And so the first thing that we know is to get the total grams of our compound, we get that through the molar mass, which is something we learned in part 2 of this study guide back in skill 4, I believe. And so to find the molar mass, we would list out our elements. We have chlorine and oxygen, and we count how many we have. Chlorine has 2 of them, according to the subscript, and oxygen has 7. We multiply by their mass on the periodic table. Chlorine is 34.45, although I just did that off memory, and I have a feeling I'm wrong. So give me 1 second to grab my periodic table off my desk, because we should always double check. And I was wrong. It's 35.45. I knew something was off about that. And then oxygen is 16. So we use our calculator to multiply. So 2 times 35.45 is 70.90. And 7 times 16 is 112. Your calculator doesn't tell you that it's got your 2 zeros as your decimal, but they are there. And we add it all together. And so when we do this, we get 182.90 grams per mole of Cl2O7. Now that is our total of our compound. So if I want to know the percentage of chlorine that is in this, that would be my grams of chlorine. So that would be, that's my grams of chlorine. This one here, that's my grams of oxygen. And this one is all of it combined. That's the total. So it would just be 70.90 grams divided by 182.90 grams times 100. And when we do that in our calculator, remember that the 70.90 has to go in your calculator first, we get 38.8% chlorine. So that means out of all of that 182.70, 38% of it is chlorine, which means the majority of it is the oxygen, which we can see because if we calculate our percent of oxygen, that would be 112.00 divided by 182.90, and I should have grams at the top, times 100, 112 divided by 182.90 times 100 gives you 61.2% oxygen. And that is how you calculate your percentage. So you should be able to do question number 2 on your own. So go ahead and pause the video and press play when you're ready to check your work. Okay, now that you've pressed play, you should have worked out your problem. And one thing you want to check is that 61.5% oxygen is your final answer, because they want to know specifically the percentage of oxygen, not aluminum and not hydrogen. If you didn't get that, the most common mistakes are potentially not multiplying your 3 for your subscript to both oxygen and hydrogen. So you should have had 3 of each of those. Another common mistake is here, instead of using the number 48, you might have used 16, which is the molar mass. But remember, you have to use the total amount of oxygen in your molar mass. And so those are your most common situations. Now, the 11th skill we learned is about empirical formula. Now, when we talk about chemical formulas, we talk about the letters and symbols that represent the elements on the periodic table, or the elements that are the atoms that are reacting in our molecule. Now, an empirical formula is one that shows the smallest whole number ratio of elements in a compound. Okay, and it can be found by simplifying the molecular formula. Okay, by the greatest common factor, or your GCF, which you should be familiar from your math class. And so it can also be determined by the percent composition. So there are 2 ways to figure it out. I can give you the percentages and you can determine the empirical formula, or you can have the molecular formula and just simplify. So question 1, you can see that they give you the percentages, and so that means we need to look at the poem. So at the bottom of your molecular formula, there's this diagram here. So if you are starting in percent composition and going to the empirical formula, I give you a hint that in class we learned about a poem that tells you the steps. Okay, and that's what we're going to be doing. Earlier, we started with our empirical formula, and we did our molar mass and our percent formula to get that. Okay, so we already did this. This was skill 1.10 that we did at the beginning of this video. But now we're going to look at the poem. Now, the poem goes like this. It says percent to grams, grams to moles, divide by small, and multiply till whole. Okay, multiply till whole. And each line in this poem is a different step. So the way you change your percent signs to grams is you assume 100 grams. So 69.94% of 100 is 69.94. So you literally take, if you write down, which we'll actually make these all different colors. So I'm going to make step number 1. Oh, let's try that again. I'm going to make step number 1. Never mind. Step number 1 we'll do in purple. So I'll just write over it. So purple is going to be step 1. So we write down what we have, our percentages. We have 69.94% iron, which is Fe, on the periodic table. And we have 30.06, there should be a percent sign there, of oxygen. That's kind of a typo. Sorry about that. And when we look at this, the first step is to change it to grams. Literally, all you have to do is change your percent sign to a G. It's the easiest step. That's the first thing you do, because you just assume that you have 100 grams of it. Now, the second step says grams to mole. I'm going to make this blue. grams to moles. So what this means is you change from grams into moles of that element using your mass on the periodic table and a little T-chart. So if you look at iron on the periodic table, it has a molar mass of 55.85 grams. And we're going to be dividing by that because we know that if I have grams here, grams have to be at the bottom. And so that is equal to 1 mole of iron. And we do the exact same thing for oxygen. We know that oxygen has a mass of 16.00 grams on the periodic table. So we set up these two T-charts, and we know that it'll be 69.94 times 1 divided by 55.85, and this is 1.25 moles of Fe. And 30.06 divided by 16 is 1.88 moles of oxygen. And that's step 2. Step number 3, I'm going to have that be green. That's where we divide by small. This step is often forgotten by students. So if you make a mistake, this is sometimes where it happens. You literally choose between our moles, 1.25, 1.88. Which one is the smallest number? Well, 1.25 is the smallest. So I divide by 1.25 moles for both of them because we need to create the lowest ratio that we absolutely can. And so 1.25 divided by 1.25 is just 1 atom of Fe because our moles are going to cancel out. And 1.88 divided by 1.25 is going to give you 1.5 oxygens, which I'm going to write OXY so it doesn't look like a 0. And then our very last step, which I'll actually leave in red, says multiply till whole. Because we see here, this one has a decimal. And you can't write a chemical formula that says Fe1, 0, 1.5. You cannot have decimals in your subscripts. And so there's a little hint here for you. If your answer after you've divided by small ends in 0.5, that means you multiply by 2. If your answer after you divide by small ends in either 0.3 or 0.6, then you multiply by 3. If it's anything else, okay, which this isn't part of the rhyme, if it's anything else, you just round to a whole number, okay? These are kind of like your little shortcut hints. So in our case, we see that after we divided by small, it ended in 0.5. And our hint said that we multiply it by 2. And 1.5 divided by 2 gives us 3. But again, a common mistake that students make is that you actually have to multiply them both by 2. We have to keep the ratio going the same. So that means 1 times 2 is 2. And now our final answer, those become our subscripts. Our empirical formula is Fe2O3. And that is our answer. And that's quite a bit of work. Don't worry, you would only have one of these on your final exam, but it is there nonetheless. And that is how you solve it. So, hopefully you have no questions. But if you do, there are practice problems and there are other videos and things you can do. You can ask me in class. So here it says, what is the empirical formula of a compound with a molecular formula of C2H6? So here we have our molecular formula and they want to know the empirical formula. So if you look at your chart, that means you're starting here and you're going to the empirical formula. This is our goal. So that means we divide by GCF, divide by our greatest common factor. So if I look at C2H6, C2H6 is my molecular formula. So I need to divide by my greatest common factor. So when I look at the number 2 and the number 6, the largest number that can go into both is the number 2. Because if I tried to use the number 3, 3 cannot go evenly into the number 2. So we divide. 2 divided by 2 is just 1. So that's just C, 1. And remember, chemists are lazy. We don't really write ones. And then we have H. Well, 6 divided by 2 is 3. And so my answer is CH3, because that is the lowest ratio I can get. So obviously it's a little bit easier to find your empirical formula if they give you your molecular formula. And there was a question similar to that on your performance final. But you need to be prepared for both types on your final exam. And if we look at molecular formula, okay, so we were talking about molecular formula and how we start there, but what does that actually mean? So the molecular formula is a simple whole number ratio of the empirical formula. Okay, and so sometimes the molecular formula is the same as the empirical formula, sometimes it's the same. And it can be determined by multiplying the empirical formula by N. Now, N, we know with the ideal gas law is moles, but when we're talking about empirical molecular formula, we calculate it by dividing the molar mass of the molecular formula by the molar mass of our empirical formula. So I'll write that kind of in a symbol here. So when we talk about N, or your greatest common factor, okay, it's your molar mass of your molecular formula divided by the molar mass of your empirical formula. So let's take a look at this problem. It says the empirical formula of a compound of boron and hydrogen is BH3, and that should have a subscript. That should be written like this, BH3. Its molar mass is 27.7 grams per mole. Determine the molecular formula of the compound. Okay, so we've got a compound, and its molar mass is 27.7. So what they're saying is that this is the molar mass of our molecular formula. But our empirical formula is BH3. Well, to calculate our molecular formula is equal to our empirical formula times N. So this would mean BH3 times N, whatever our greatest common factor is. And we calculate N by using our molar masses. So first I need to calculate the molar mass of this. So we have boron and we have hydrogen. Boron, there's one of them. Its molar mass on the periodic table is 10.81. And hydrogen, we have 3 of them times 1.01. And we get 3.03 for those. We add it all together, and we get 13.84 grams per mole. So that means for N, we take the molar mass of our molecular formula, which we get from our problem, 27.7 grams per mole, and we divide it by 13.84 grams per mole. And when we do that, your calculator gives you 2.00, so basically it's 2. Your greatest common factor is 2. So that means my answer would be BH3 times 2. Well, that gives us B2H6. And that is my final answer. And I know I kind of like showed y'all everything and went kind of long, but that is how you solve it. And so remember, we have this diagram here that can help give you a hint of, okay, if I'm starting here and going here, what's the pathway? Or what if it's the reverse? I multiply by n. And yeah. So hopefully that helps. And in the next video, we'll start looking at Avogadro's number.